This week we're going to talk about the difference between how the hormonal theory, sometimes called the insulin model, differs from the calories model, and why that's really so important to understand when you're trying to lose weight, because it's more than just about calories. It's all about the hormones as well as the calories, and it's coming right up. In the traditional model of weight loss, we're really only concerned about calories. And this model says that food, in terms of its fattening effect, really is all down to the energy that it contains, which is what calories are. It's the amount of food energy that's contained within the food, and it's determined by burning it in something called a calorimeter. And the American Heart Association, in its scientific statement for 2021, which just came out about a few weeks ago, said this exact thing. So in their scientific statement, they said, number one, adjust energy intake and expenditure to achieve and maintain a healthy body weight, which means that the only thing that they feel is really important is the energy that is contained within the food. So if you adjust the energy intake and expenditure, then you're going to do fine. Nothing to do with the hormones. The hormonal model takes a different sort of approach. That is to say, food contains not just energy, which is calories, but also information as to what to do with those calories. That is, different foods are going to elicit different hormonal responses, and when they do, our body does different things. So our body can burn those calories, for example. It can store it as body fat, and which one it does is determined by the hormonal mix of those foods. And this model, sometimes called the carbohydrate insulin model, is promoted by Harvard scientists such as Dr. Walter Willett, Dr. David Ludwig, and other luminaries, which is in this paper from 2021. And the main hormone that they talk about is we know about insulin is that when you eat, particularly carbohydrates, but also proteins, the hormone insulin is going to go up. So this is called a nutrient sensor. It tells the body that nutrients are coming in. When it does, it's going to stop the breakdown of glycogen, which is a form of stored calories, and body fat, which is also a form of stored calories. And it's going to increase the synthesis. In essence, insulin is telling the body to store those calories, either as sugar, glycogen, or body fat. And it stops the breakdown. So, the energy balance equation is usually written as this: body fat equals calories in minus calories out. And this is always true, and nobody's denying that. However, there's really no such thing as a caloric deficit. Remember, this is a balance equation, which means that there are three variables here which must balance. There's body fat, calories in, and calories out. What it doesn't mean is that if you simply adjust one of those variables, you can determine which of the other variables is adjusted. Usually people say, well, if you simply eat less, that is, reduce the calories in, that is going to be balanced by lower body fat. And your metabolic rate, which is calories out, is going to be unchanged, because those are your three variables. Decrease calories in, decrease body fat, calories out stays the same. And they usually count it in terms of the first law of thermodynamics, which makes it sound very sciencey. Unfortunately, it doesn't apply here, because there's a second alternative to what happens if you eat fewer calories. Looking at this equation, you can see that if you lower the calories in, you can just as easily balance this equation by lowering calories out. That is, your metabolic rate, the number of calories you burn in a day, may well be decreased and your body fat is unchanged. And this does not break the first law of thermodynamics, which is usually thrown out there as proof that eating less causes lower body fat. In fact, there is no such equation that says that. There are three variables. So, reducing calories in can either reduce body fat or reduce metabolic rate. Both are equally. And which one happens? Well, let's look at the studies. In 1944, Dr. Ansel Keys did a study called The Biology of Human Starvation, where he was looking at what happens to the body when you reduce calories. And this was because it was the war and they were worried about what happened after the war when people didn't have enough to eat. So he took a number of volunteers and he gave them a low-calorie diet. So it wasn't starvation. In fact, he gave them 1,570 calories per day, which was a 40% reduction from their typical. And mostly very starchy, low protein, low fat foods typical of post-war Europe. So, interestingly, this is almost exactly the diet that most weight loss professionals tell you to do. 1,500 calories a day, low fat, low protein, therefore low calories. And what he did was he measured their metabolic rate before and after. And when you reduce the number of calories in by 40%, he found that their metabolic rate also decreased by 40%. Their heart volume shrank by 20%, their heart rate slowed, and their body temperatures dropped, in amongst a number of other things. And this has been a consistent finding for the last 70, 80 years. When you decrease your calories in, your calories out also decreases to match. This was from 1971, where Dr. Apfelbaum did the same thing. He underfed people by about 15%, and what he found when he measured their metabolic rate or the amount of calories they were burning, it also decreased by 10 to 20%. That was 50 years ago we already knew this happened. In 1995, Dr. Leibel, in the New England Journal of Medicine, did a very interesting study where he took people, he gave them the same diet, he force-fed them, made them gain weight, and then their metabolic rate also went up. When he returned them to their initial rate, it went back down. When he made them lose weight 10 to 20%, what he found was that their metabolic rate also went down. So it went down by about 300 to 400 calories per day. So if you're eating fewer calories, but your body's also burning fewer calories, well, your body fat percentage is going to be unchanged. This meta-analysis from 1991 looked at all the studies that had been previously published. This was 30 years ago. Looked at 29 published studies and looked at the relationship between calorie restriction and the change in the resting metabolic rate. And you can see that whether it's a short study or a long study, virtually all of the studies show a decrease in the metabolic rate by about 10 to 25%. Their conclusion was this: the first statement, which can be made with some certainty, is that a decrease in energy expenditure is a universal response to energy restriction. That is, if you eat fewer calories, it is a universal response. That is, we see it in virtually every single person that they will burn fewer calories. So, this is a representation. Suppose you have these three variables: energy coming in, which is calories. And I've depicted it here like coal. For example, in a coal burning power plant, you can have coal coming in, you can burn the coal, or you can store it in a warehouse. Our body has the same thing. You take energy in the form of calories, and you can store it in the form of sugar and body fat. So in sugar, you produce glycogen, which is glycogen synthesis, or you can produce body fat, which is called de novo lipogenesis. When you burn that energy, that's mostly for metabolism, and exercise is a much smaller part. The most important thing to see here is that when you eat, the insulin level goes up. So when that happens, you can either store those calories or you can burn it. And that's the only way it goes. You cannot take the body fat and use it for energy, because insulin inhibits lipolysis. Your body has those instructions to store energy, not burn it. So you can't take the energy out of the warehouse, which is the body fat, and use it for metabolism. So when insulin is high, the hormones are going to determine which way these arrows go. It's only when your insulin levels fall, such as with fasting, that you can now take the energy, the body fat, and use it for energy. So let's see what this means in the real world. Suppose people are eating 2,000 calories a day and burning 2,000 calories a day. So body weight is going to be stable. Now you want to lose some weight. So what you do is you follow the standard advice and you reduce the daily food intake to 1,500 calories a day. But you're eating constantly, you're eating very high carbohydrate food, so insulin levels stay high. So this is not balanced. You have 1,500 calories coming in, your metabolic rate is 2,000. What you try to do is you try to take those extra 500 calories from body fat, but you can't because the high insulin is going to block that. So because it's not balanced, what's going to happen is that the only way you can possibly balance it is that the metabolic rate has now got to fall to 1,500 calories. In other words, you're decreasing the number of calories out, your body fat stores are unchanged. Let's look at a different example where you have the same number of calories but a different hormonal profile. Here you're going to have periodic fasting where you're going to allow that insulin levels to fall, which is going to allow you access to the storage that's in the body fat. So same 2,000 calories in, 2,000 calories out. You reduce your calories to 1,500, but you also reduce how often you eat so that your insulin levels fall. Your body wants 2,000 calories. You only got 1,500 coming in, but now because your insulin levels are low, you can actually release those extra 500 calories, and therefore you can keep burning the 2,000 and your body fat levels are going to go down. So this is the hormonal model, which is that food really contains two very important factors. One is the energy, which is the calories, but equally important is the information that is carried in the food as to what to do with that energy. Both of those are very important. If you only eat once a day, but you eat way too much, well, that's not going to be great for weight loss. But if you eat fewer calories, but eat all the time and access to the body fat stores, that's also going to be not as successful. So those are the two models, the caloric model and the hormonal model. And you can see that they don't actually say anything different. But the hormonal model is a much more comprehensive understanding of how our body processes those calories, because it takes into account the amount of energy and the instructions of that energy. The calorie model, which just says just count your calories, actually takes no account of the instructions that are given to our body. And that's why it's been so unsuccessful. For the last 50, 80 years, we've known that simply counting your calories and cutting them is not a successful way of losing weight. If you want to lose weight, you also have to let your insulin levels fall. And the best way for that, you can use intermittent fasting. You can also use low carbohydrate diets. I hope you've learned something today. If you did, please share it with somebody. And if you're interested, you can also check out this video about fasting and how it's going to really work to help you lose weight. Thanks for watching.